What you guess by this topic? What innovation inspired by nature? So, any guess? You can unmute and you can openly say anything. Questions like,
Somebody put in chat using biomimicry for innovations.
okay, okay. Hey, thanks, Vikil. I think you helped me understand with the chat box also. So,
Mm.
using biomimicry for innovations. Okay, good. So, but what is innovation? Like, what you understand by innovation?
Trying something unique.
Okay, trying something unique. Good. Any other viewpoint?
People are putting in chat box. There's
A new method of doing something. Okay. Upgrading the available products using biomimicry for innovations. Uh, so what you call like someone said making something unique. What is unique then? What is innovation? Like Chaku sir has told you about lot of things about innovation. You have gone with the spoon methodology. So that's a process. But moving ahead, I think let me introduce like as you're all from COEP. I was also from COEP. I passed out in 2005. Then I worked for a couple of years and then I did my master's in industrial design from IIT Bombay. Then again, I was part of Sena Innovation Studio and then I joined the Crompton. So this is my overall journey. And these are some of the projects which I have worked on. Uh, some might like the spoon which you have seen is already was there covered by Chaku sir in their earlier presentation. So you know how that innovation is carried out. These are some of these recent projects which I have worked on. You might have seen these products in market as well. Uh, I have a hobby of origami craft. So if you like, you can follow me on Instagram. These are some of these projects which I have done with Mumbai airport, where the prominently animals from the northeast were designed in origami way for that particular event. Then coming back with the uh, yeah, innovation. So what do you guys think about the innovation then? What these slides tell you about something? Does it tell something you? Okay, so let me like innovation uh, is uh, is like these so many scattered dots in our entire world. So when you try to bring the connection between the dots, we try to find certain common things, and then it all becomes about the connecting dots. So two unrelated things, when we see a common factor and try to connect those, we come up with something new. So that's about innovation. Like, is any question here? Like, okay, so we were here to discuss a biomimicry, which is one of the way of innovation. Like this way, you can achieve the innovation. So what is biomimicry? So if we see, bio is nature, right? Everyone knows that. Mimicry is as simple as it sounds. It's imitating something. So if you combine both words together, it becomes a mimicking the nature or imitating something from the nature. We also get the word of inspired from the nature, right? because nature has that 3.8 millions billions of years of history. So that experience we can utilize here. So that way we can say that we can biomimicry is a technological oriented approach focus on putting nature's lesson into the practice. Or to put it in a simple word, let's say let's solve human problems by mimicking nature. This is as simple as this. So I think you can also see from this angle for innovation. Have you heard any example of biomimicry? I think you might have, like you're so curious and eager for innovation. Any example you heard? Okay, that's great. Bullet train. So Nitin has said bullet train. Any other example? Nitin, you want to elaborate what you want to say? You can unmute and say. Oh, sorry, is Isha, right?
Yes, sir.
Yeah, yeah,
Good evening,
yeah,
sir.
yeah. Hi, Isha. So, any you want to touch upon bullet train biomimicry?
Yes, sir. The Japanese bullet train was inspired from the beak of the kingfisher. So it has a like the engine is shaped like the beak of the kingfisher.
Okay, interesting. Like it's you're very correct. I included that in my slide also. So, can you elaborate why? What is the problem they have solved there? Like here we're talking about solving the human problems by mimicking the nature. So, what is the problem which they have solved there?
It gave the train a very aerodynamic shape, so there was no restriction on speed. It could run at high speeds.
Okay, okay. So, I think thanks, Isha. I think you had touched upon very interesting point. So, this is a train which I think she was referring to. It's definitely inspired from the Kingfisher. So, there was a unique incident like when this tunnel, the train used to pass through the tunnel, it used to create a sonic boom, and because it's moving at very high velocity, boom was dangerous. It could cause some uh, vibration across the region, and it is heard for a longer distance. So when they have seen this kingfisher, the kingfisher has a unique ability that when it passes from air to water, when that bird dives in, it doesn't splash a drop of water outside it. So it was so smooth that it goes in without splashing in. And that the same they have implemented with this bullet train. And with that, the sonic boom is also reduced. And when they have also got the energy efficiency of this train. So these both advantage they took from this biomimicry example. So there are n number of example like this. Thanks Isha for pointing out this example. Another example is that can you guess what animal is this? Sorry, I not put the entire image of animal, but any guess what is this?
It's a humpback whale.
Whale.
Yeah, yeah, great, great. I think you did a lot of good research. I think I really appreciate that. Thanks, Nakshatra. So, what is that humpback whale and this uh, machine-looking product as common?
Turbine.
Okay, so yeah, this is a wind turbine. So what they did, so when these whales, their front uh, fins, their leading edge has this particular pattern. And when we learn in aerodynamics or fluid dynamics that we think that a blade profile should be smooth, it should not, so that there not be turbulence. But with this profile, the kind of pattern which it gives, it reduces the drag on the blade and improves the efficiency of this wind turbine. This also a good, great example. You might have recently seen that MIT Media Lab, they have developed one uh, biomimic robo for a dog. So it can handle, like, even if you kick it, it stabilize itself. It can carry a weight also in extreme terrain. So this is also example of biomimics. So so considering this case study, like the problem was about the ceiling fan. So have you faced any problem with ceiling fan sometimes? So taking it ahead, this is kind of iconic ceiling fan which everyone has in their room. So are everyone happy with their ceiling fan or no? How it is? You might have in your hostel as well, right? Hostel classrooms everywhere. Wherever you go, you see the ceiling fan. So ceiling fan generally used for our cooling comfort. So we need certain amount of airflow in our body to feel cool, especially in the current summer. So when we're designing, we found the ceiling fan has a problem that, okay, sometimes they do not have efficient airflow. Okay, uh, Isha, thanks, Isha. Uh, Apart from that, any other? Okay, weekend noise, good. So I took this ahead, and like when we're having a watching a TV, and we need to increase the volume of TV. Why we do that? That when because the ceiling fan operates at very high speed, it makes noise. And when two people are having a good dialogue, or when we have a phone talk, we can't hear what the next person is saying. So what we do? We either reduce the ceiling fan speed or we try to increase the volume, which actually not good for us. So there is one discomfort. Actually, the ceiling fan is used for having a comfort, for thermal comfort, we can say. But same times, from noise point of view, it making a noise and making us discomfort. So isn't it there is some contradiction? Like the fan which is used for comfort is also causing a discomfort. So that discomfort was also causing discomfort for me, and was taking this problem ahead for resolution. So with this problem, like I had one day of outing and was going from the ferry tour, and interestingly there were some seagull birds appeared which were following the this ferry. And that time I noticed that this bird, even they're traveling, following this, they're not flapping their wings often. And there is very something special about the seagull. uh, does anyone know what is the special about seagull? I know this is very out of syllabus questions, but I think so. If you notice or if you observe, seagull is the only bird which you find inside the ocean. Like there are crows when people, yeah, yeah, correct. PM, I think, thanks. They can fly for long time in sea, correct? Because for doing that, they don't spend much energy. What they do, uh, they use the air current which happens on the ocean surface, and they adjust their wing accordingly, and that's why they can able to fly so many distances inside the ocean. So these are the seagull birds with close up. You can see their profile. Some more photographs. So I took all as many as photographs possible. Then I came back. I researched more like this, whatever I am talking about, that these are the birds. Like there's a good case studies available, research papers available. And after studying that, uh, I said, why not connect this dot together? Like one is a single bird and the ceiling fan.
देश पडते. अरे ऐक ना त्याचं सीन. सकाळी जिमला येतो मी तो. कसली खतरनाक जिम मारतो.
Vinith, you want to say something? Okay, so as we have already seen that seagull birds use the wind currents and fly for hours with minimal effort. So this is the trigger point which I took. And then I studied in detail, like whatever literature available. I took the actual, took help from the some museums, research papers, and I have developed one profile which will suit a ceiling fan kind of uh, structure. And this is, you can see this slide. It talks about the detailing of the wing bird and the how the profile is converted into the blade. So there are a lot of iterations went because this profile is very difficult and it varies from hub to tip and from trailing edge to leading edge. There is continuous variation observed. And this connect of a seagull bird and ceiling fan uh, is ended up as a this biomimicry project where this image clearly shows you how even the color theme is also inspired from the seagull bird. But taking ahead is not that simple actually. So being a corporation, we need to always bridge this gap. So what is this gap? So these gaps is about the user need and the business need, because you need to join both these user needs with the business need to come up with the business case study and then move ahead. So with that proposition, like where we have mapped all the ceiling fans and proposed where this fan will be, uh, at initial level it was very difficult because this fan earlier, all ceiling fans which are making so much noise, if you see here, those were efficient, but they were running at very high RPM. But this fan where which I have proposed was I proposed concept which is having operating at a lower speed, so that, and with this profile it will deliver same amount of air, but it will operate at the lesser speed. So that was one of the contradiction which we need to push with the our marketing team and business team, that even if this has a lower speed, it can deliver same amount of air delivery. So for that we made this concept, we have done detailing, we made actual prototype of these fans. Sorry, we made the prototype of this fan. Then we have done this raw tooling. If you see in the right corner, we have done this raw tooling and actual blade from this aluminum sheet we have molded. We have tested those with actual physical condition, and also we have done a simulation where the air delivery parameters, the functional parameters are checked, and then we again approach business that okay, this fan will deliver the amount of air, and but it will also deliver, operate at a less noise, and will provide more comfort to the users. So I think the slide which currently on display will uh, help you understand how this fan blade profile is. So as a company, we have filed a patent on this profile, fan blade profile. So design also helps to lead this uh, IP rights like patents and design registration. And this image will illustrate you how these components are assembled, like what is each component made up of, how it will be painted. So these detailings were added later on. Then finally we have gathered the whatever current trends were at that time, and we have proposed accordingly some of these color themes for this fan. And this was the concept render for the ceiling fan, which was proposed as seagull ceiling fan. And then this is the final concept which we arrived at. So this fan is a silent, it's much silent than the existing high speed fan. And this is the India's first plastic blade fan which has the profile included in it. So, and nowadays if you see, there are other silent fans are also available in the market. Any questions at this point?
Sir, which factor in this fan make a lesser noise?
Yeah, so if you see, like noise is very critical parameter. Like the existing ceiling fan, which operates at high speed, so they run at 450, 400 to 450 RPM. And if you see the blade profile, their leading edge, their trailing edge, even at the tip of the fan, there are certain times there a flapping of fan blade happens, which creates a noise. So if you see this fan blade profile, it has varying cross section from hub to tip. And if you see at tip, it get narrowed. It becomes a like narrow tip. So at the tip, whatever the vertexes are there, those were not there, which were causing the tip noises. And because of this aerofoil shape of this fan blade, it is moving smoothly through the air and operates at less sound level. I hope I have answered your question.
Yes, sir, got it.
And this is the side view. You can see the clearly, like even most of the current ceiling fan, what happens, like during Diwali and other occasion, you try to wipe the fan blade with your wet cloth, or you can clean it. But while doing that, you also damages the blade profile. So as you go on cleaning, after some years, the fan noise increases because the blade profile which was earlier, that was not maintained later on. So it keeps on changing if you clean it. But for this, you can if even wipe, take it out and clean. The profile is not gonna change because it's molded with the form. So it's along the life of the fan, the profile remains constant. Even whatever the canopies which are there, like whatever, like this profile also is very made smooth, so it will have least resistance for air, and that will guide us. That smooth path will have lesser noise always. This is the final product. Any question from anyone? Like to understand anything detail? Uh, was this case study interesting to you? So any takeaway, like you can say what are the takeaways from this case study, like?
There is a question by Nakshatra in the chat.
Okay. Yeah, as the surface area is increased, does it consume more power? Power, see this fan, like it's about the motor design then. The surface area increase, power, when you throw the same amount of air delivery, you will require the same amount of work done for the fan blade, right? So that way it was consuming about same kind of power, uh, because you need the same amount of work done. What is giving a advantage is that the noise is reduced in this case, because considering the motor efficiency and the input power, because our work done required same, it will have a same power, unless because this project was launched in 2013. So that time we have launched with the induction motor. I think nowadays there are BLDC motor also available. So with that it definitely have a less power. But that time it was matching with the standard ceiling fan power. The motor design was tweaked to have a to make it work on the lower RPM. That time we need to increase the torque of the motor, and overall power will remain same, because speed into torque will remain constant, right? So that's the logic. Any other question? I think we have reached at the end of the slide.
Please, students, ask questions if you have or anything. We have
I
10
kept
minutes.
this presentation very optimized so that we can have more time for discussions and dialogues.
What are the ways to right?
I missed, sorry, someone was saying something.
Aman, you
Hello?
were saying something?
Yes, sir. What are the
Your voice is not clear. You can type in the chat as well if you have any question. Uh, there is a question by Mayur in the chat.
Okay. Mayur, your question, what should be the first thing we should do when we observe such resemblance or get any idea? Uh, I think this is a bit of generic questions. Can you be more specific?
I think he is asking like when you saw the seagull and you got an idea, so what should be the next step? I think he's asking in that context.
Okay. So I think this journey is not that smooth as we see in the presentation. There's a lot of up and downs. Like generally, while actually this idea when struck to me, uh, uh, we need to get into more details. And because these dots are not connected earlier, we definitely have an opportunity to connect those. But for that, we need to run an extra mile. For running that extra mile, we need to gather more information. We need to study those details. We have to think that in product how this can be implemented. So what are the triggers which we can take out from this biomimicry exercise? How to put it? So those were those things you need to practice. You need to spend more time, effort on this.
There
Say
is
even like finding these like if you have certain problem, there might not be any straightforward analogous example available in the nature. So sometimes you have when you're searching about that problem, uh, what is the crux of your problem will guide you to the respective inspiration. For example, if you want to make a structure very light, you can take example of a feather. Like it has a hollow stem, it has those spread across pattern. Even if you want to make a very strong base or something, you can take example of bone structure, trees which are standing tall, like trees, the branch structure. Now recently, I think if you follow like the MIT Media Lab, they have come up with the structure which is using trees Y sections. So you might have aware that the straight sections are only used for woodworking, right? But what happens with that Y sections, which actually the where the branch starts? So they cut that and throw away. But actually, those parts are very strong considering the design, and those are now getting. They have proposed to use those for joints of the structures. So these kind of inspirations will do fall in if you pursue on this your journey to explore the problem further. VK, over to you. I think any other question?
Aman in chat has put, how can we pursue career in design? It's a very general question.
I think you already started that path, right? Like being enrolling for this course itself shows that you have inclination towards that. So there are other once you start like Jakku sir has also taken you through these courses. So further you can explore your career with like say design courses like in masters or in industrial design or product design that will lead you to the next stage of design.
Sarang, I just have a question about the fan.
Yes, please.
So, the shape of the fan leaves and blades, do they
Mhm.
also like affect the shape of the air tornado which it creates? Like, do you consider that variable as well? Like, for example, in a 10 by 10 room, this shape blade will create this kind of tornado, or if you change the blade shape, then I'm my question might sound very ambiguous, but like if you change the blade of the shape, does it also affect the reach of the air in the corner of the room? Uh, because it will also change the in way the air moves around the room, right? Uh, do I sound?
Yeah. You're absolutely correct. Like, uh, I'll just articulate. Like, your question is about like if we change the blade profile, does it change the characteristics of the air thrown in the room, right?
The shape or the movement in which the air flows in the room,
Yeah, definitely.
because
Like,
it
yeah,
might get very concentrated, it might spread out more by changing the blade shape of the blade. Just asking.
correct. So, that does happens. Like, even if we increase number of blades, if we increase size of the blade, even if we increase the angles and surface area of the blade, all things are very critical. And like what which I have shown that when we did actual prototype of this fan blade, like also for your spoon case study, sir has taken you through all the different material explorations. So that gives you experience, like how that blade will behave in real life. Or we also have certain tools available, like these are like CFD simulation are there, flow simulation are there. So these techniques are used that to map how the performance of this profile is,
Okay.
and then we can take a call that okay, if this is a profile, if I tweak this, what will happen. So to arrive at this particular fan blade profile, there are n number of iterations have gone up. We have made n number of prototypes also went in different direction, which we actually failed in those prototypes, but we learned from those that this okay, this thing will not work,
Mhm.
this thing will work. So that's called a fine tuning. So from prototype to prototype to prototype, we got more refinements. Then in digital version, we made more refinements. Then for manufacturing, you need to have certain constraints. Like if your mold is simple, if it's made in simple core and cavity, it is easy to manufacture. So for that also, you have to do certain changes in your blade profile, because your blade should not have that sharp uh, edge, which we call it flash in the molds. So those small detailing, designing for manufacturing, design for quality, those things has to be considered when you move from concept to actual product implementation. It's a long journey. Uh,
I understand. Students, anybody have any questions? Any more questions? You can put in chat as well. We have 5 minutes left. You- I don't think anybody have any questions. Do you have anything more to add? Anand?
no, I think it's great. I think it's great session. Like thanks for this opportunity, and we also got a very interesting questions. So
Okay.
I really appreciate that time, because I understand for students spending evening with this kind of lecture could be challenging. But thanks for being here. If you have any questions, you can approach, like you can come with, you can get in touch with VK or Chakravarti sir. We'll try to answer those.
Actually, my name is Mridul. The VK is the account
Okay.
name which I'm. My name
Okay,
is
okay, okay.
Mridul.
Yeah. Thanks, Mudul then.
Okay then.
And thanks, Mudul, for organizing the entire session.
Thank you. Thank you, sir. So
Hmm.
we can close it now. Okay.
Yeah, is good to close.
Okay then.
Have a great evening. Have a good night.